What's up, everybody? So today we are out in front of the 150 watt hybrid Pro from OMTech, and we're talking metal cutting. So hang on tight and let's get into it. So in order to do the metal cutting on this machine, there's a couple of things that you have to set up. So we're going to go into first the oxygen tank, how I have that set up. Second is the nozzle assembly, which I actually already have a video for, so I'll only go over it briefly here and tag the video. And then there is the metal bed, or the sawtooth bed that you have to put in. That one's super easy. Lastly, it's going to be using the head, getting things calibrated, because there actually is a sensor that actually goes and it's able to tell how close it is to the metal. So it's important to know how to operate that head, get it calibrated so you can actually do clean cuts and make any adjustments that you need to. So let's jump over to my oxygen tank and we'll talk about that first. All right, so here is my oxygen tank. This is a 125-pound tank, and one of the first questions that people have been asking is, how big of a tank do you need? And I'm going to return that question with the question of, how often are you going to be cutting metal? Because that will determine how big of a tank you want. Really, you could do it with a small tank, but that means that you potentially only are able to cut for so long before you have to refill it. So 125-pound tank, pretty good size. It's going to last me for a while because I don't do a ton of metal cutting. So jumping into, the tank itself, it's similar to like a propane exchange. You go to like a welding gas supplier. You can set up an account, figure out a lease, or you can buy a tank outright, and then you just exchange it to them and pay the exchange fee for when you want it refilled. The regulator here, I actually got this on Amazon because there was a regulator that I had that it didn't work. For some reason, the fittings weren't working out. So I just bought a new one, and this is how I set it up. So all of this came as one piece. So including this tip here, it all came together. So then I took some 8mm air hosing that is the same connection that is on the back of the machine, and I set it up with this little quick connect tail. So that way I could switch between my compressor and this oxygen tank pretty easily. Granted, thinking about it, hindsight 2020, I could make a Y with a valve that shuts them off, one or the other. This was easier, so I could just disconnect it, put it away. Keep in mind, I have my tank sitting out here right now so we can look at it. Normally it's back, it's on the wall, it's lassoed so that way it can't tip over. You want to make sure this thing is sitting somewhere where it's not going to tip over, the top's not going to break off, like it doesn't cause problems. You don't want a tank shooting off somewhere. So that's how I have it set up. So that way I can just grab the end of this tubing and just connect it back up. So that way it's in there nice and tight and it won't come out. It does pretty well. I've not really heard any leaks, but when you're done, shut it off. Close the tank, be done, like walk away. You don't need it to stay open and connected all the time. So that is the tank, and then this hose goes back and it connects to this connection right there. So that is for your air assist or O2. I use it for both. There are ways that you can just use it for your regular compressor. Right now, we're ready for the metal cutting with the oxygen. As far as setting up the actual regulator and setting up your pressures, open the tank all the way. This will pressurize, and then we need to set this guy. So go ahead, and there we go. So you can see the pressure coming in on this gauge, and this is where it is over here. So per the manual, it says to put it at 75 to 140 psi. You can see that this one caps out at 100, so I'm not going to go that high. It also references it as 5 to 10 bars, which is these black ones out here. 1, 2, 3, 4, 5, and that's right about where 75 is. So I'm actually going to back it off just a hair. We won't see the actual measurement until we start running some oxygen through. So you'll want to watch this. Once it actually starts running through the machine, make some adjustments. So that way you can get this and have it right around 75 or above. because if it goes too low, it may not intensify the cut enough, because that's what the oxygen's for. It helps intensify that cut and the heat for the metal cutting. All right, now let's talk about the Sawtooth bed. So the pieces that I'm going to test on and I'm going to use to show you this demonstration are not very big. So I'm not taking out all of the aluminum blades. I just put in this section of Sawtooth because the piece that I have, at least one of them, is only about yay big. So I don't need all of this space to do it. But granted, keep in mind, if you're going to be cutting some big sheets, you can use it all. There's plenty of blades in there, because here I have them still packed away down here that I could add more. So we've got this set up, and really there's two different slot sizes. You can see there's a bigger one and a thinner one. So the Sawtooth fits in the thinner one. The bigger one is where the aluminum blades go. And so they just slide in there and they're ready to go. Next on the list is swapping out the actual nozzle assemblies. So in order to save time in this video, I will just link the video that I did earlier up above, and here it is. So this is the head, and that's what it looks like. Goes on the bottom, and then the wire connects the head to the actual box that controls the follow head, which is with this controller. So we will just, and there we go, ready to go. So now let's jump into how you actually do the configuration with the follow controller to get set up and ready for metal cutting. So the first thing that you have to do once you have everything else set up, you've got the oxygen set up, you've got the bed put in here, you've got the nozzle changed, is you need to come in, turn on the machine, and in the controller, you have to change it to follow mode. That can be done in two places. First, easiest, it's right there. Oh, right there. So you can see now it says follow mode. This is normal mode. You just click that part of the screen and it goes back and forth. So you need it in follow mode so that way it can actually use the controller here. You can also do that in here in some of the other settings, but I can't remember where it's at. So I don't really care. So now we are here in follow mode, and it puts this controller into wait. It's just kind of sitting and waiting. What you need to do is you need to get the bed high enough so that way you can start using the actual follow head here. So that's what this guy does. It actually will adjust the head up and down and move kind of with the curve of the steel. So what we want to do is we're going to go ahead, we'll get this, let's say, I don't know, an inch away. And then I'm just going to hold this down button and you'll see the head start to move. Ever so slightly, it's slow, but it's moving. You can see that there's a gap forming over here. So it's moving. And the idea is you want to get this close enough so that way it's touching and you can actually see some of these values change. So like this signal here, I can see that signal is going up because it was actually touching. So as I lift it, the signal changes. Get closer, and the signal gets tighter and tighter tolerances. So right now it's even saying it was actually touching, and so it was giving me a warning. So right around 8,000, or sorry, not 8,000, 80,000 is where the signal is pretty much saying, hey, I'm touching. So we'll get this back up a little ways so that way it has enough room to run its thing. So about a 1/4 inch from the metal. Then you come in here to this setup. Then you go down to calibration and enter, and it will start to go and move the head down so it can check. And then it says, check touch, okay, and calibrating. So it actually moved the head down, it sensed the metal, and now it's lifting all the way back up and all the way back down, just letting it know what range of motion it has. So now it's gone and it gave me an excellent. So excellent is the setting of, hey, I can sense where the metal is, I've got everything good, excellent. So you want good or excellent, and then you say save. So you'll just do enter, and it saves those settings. It saves that calibration. You have to do this every time you set up for metal cutting. It's just make sure that the nozzle is checking the metal and that everything is good and ready for your cuts. So now that that is done, we can actually get into the light burn and set up all of our settings so we can send a cut over here. All right, so the first thing that we're going to try here is I've just got a circle. Everybody loves circles. Circles work. So this is a 10 millimeter circle that I have designed here, and here are the settings. So the manual that I have, it recommends 12 to 18 millimeters a second at 70% power, both max and min. One thing that I have come to notice is inside of this advanced setting, you have the option to add a lead in and a lead out. With metal cutting, it is nice to have this in here. So what the lead in and lead out does is it gives a little bit of a line into your cut before the actual cut starts. And so that makes it so you have a cleaner cut, and rather than a big blob where the laser first starts cutting. So we'll look at this, and this shows you. So this is the lead in and lead out. So as I go ahead and I roll this back, you'll see what happens. So it slides in and then goes into the cut and then slides out. So that's what I'm going to go ahead and do on this one. The length of that lead in was only 5 millimeters on a 10 millimeter circle. Honestly, I don't think you need much more than that. You could probably even go a little bit smaller, but let's try this out and see how it goes. All right, so I've got everything set, ready to go. I turned my exhaust fan on, so it's pumping all the air out. And I also sent it over to the controller so we could watch it here and I could get all the video for you guys to see what's going on. So first thing I need to do is I'm actually going to hit my origin, and let's go ahead and we'll just frame it real quick. So it's showing me right there, that's where it's going to go. It's going a little bit off, origin again. Okay, so just this small little spot right there, and that's all we're going to do. So the follow controller in the metal is all set up to trigger the air assist as it sits stock. So all I have to do is hit the start button. It'll open up the oxygen and start the cut. So let's take a look. Okay, so this is what I am seeing so far from some of my testing. So this is a cold rolled steel. It's an 18 gauge, so you can see it's a little bit thicker. You can kind of see it. There we go. But the cuts are not coming out super clean. It's more like turning it in, it's like melting it. And I'm not 100% sure why. Maybe this isn't a great material to use. But then I've got this guy that is more of like a stainless steel, and I've also had some other that are like a galvanized, and the cuts are pretty dang clean. Like you can see right there, cut straight through. You can even see some of those shiny little mirrored pieces down there. So that is from the galvanized, or this steel right here. So it does work. So let's try something a little bit more intricate. Let's see if we can find like I don't know, a skull or something like, hey, skulls that I can put in here and we can cut it out for you. All right, so here's the skull that we're going to put in here. And as I look at the preview, these lead ins and lead outs are going to cause me problems. So we're going to try and get rid of them, see how things go. So we'll say, okay, come in here into my advanced, and we're just going to turn these guys off and say, okay. So now we'll go back to the preview, and it got rid of all those extra lines. So we're going to send this over the machine and see how it turns out. All right, so there's the cut. Honestly, pretty dang clean. There's not really much splash on the top of it. And I mean, because I don't know a ton about metal cutting, I mean, there might be some refining to do on the settings. There's kind of some burr, or just, I don't know, just, I'm going to call it overburn on the back. Granted, obviously, you could just take a sander and zip that down pretty quick. But there you go. So pretty quick little cut, kind of cool. Honestly, so learning from what I'm looking at here, I think I know that this can work. It just needs different settings because it looks like it's just getting too hot and it's just melting the crap out of it. So I got to come back, got to refine some more settings on the cold rolled stuff. But this guy over here is working great, and this is kind of in the stainless steel variety and other stuff that I've tested. Stainless steel works really good. Got to keep working on this to figure out what the settings are. Okay, so after going through a couple of different kinds of metal, here's the results. So this is a brass, or no, copper. This is copper. And it didn't even touch it. No marks, no sparks, no nothing. Literally went down and it did the path. Nothing. There's not even a scratch on the metal. So it doesn't work. Doesn't work. Not at all. So this is a stainless steel. Stainless steel works great. Had good settings, good cuts. Like there's a little bit of burr, probably just needs a little bit of cleanup, and would be golden. This cold rolled steel, the best I can guess is that the heat that this process produces, as soon as it hits the point where it's going to punch through, it just melts the metal. It just turns it into a blob, and it's too hot for this cold rolled steel. It's a mild steel. So just doesn't work. I'll keep trying, but as you can see, this is like a million different settings. I tried over and over and over again and just can't seem to get it. All right, so in conclusion, can the hybrid cut metal? Yes, it can. It can cut metal. Is it important what kind of metal you're trying to use? Yes, it is. There seems like it's a certain variety of steels. Stainless steel, galvanized steel seem to work well. This cold rolled steel seems to be a little bit too much. So, I mean, I don't know. Maybe it's just too thick. I mean, that is an 18 gauge cold rolled steel. Maybe if I had an 18 gauge stainless steel to compare it to, we could see kind of what the differences are, better or worse, one way or the other. But it can do it. I've used a variety of different settings, and I was even able to increase the speed on this material and still get some pretty clean cuts that actually had less burr on the back than this did. So it definitely can do it. Is this the machine for you if you're wanting to do metal cutting? If this is the kind of stuff you're wanting to do, if you're wanting to have like accents and different stuff for your sign work, or if you're cutting out blanks and different things that are this thin, then great, especially if it's for steel. Obviously, you can see the copper didn't work. It's not going to work on aluminum. It's not going to work on anything else other than the variety of steels that are good. And right now, I'm saying, hey, I'm going to use it for stainless steel and this galvanized steel, and that's about it. Outside of that, I don't know if it's really going to work for those other applications. But as a CO2 user that is doing a lot of wood projects and wants metal accents, like, yeah, it definitely adds more flair, more possibilities to your projects, and it does work well. From what I can see and what I was able to do with it, I could definitely do a lot more, and I could go bigger, obviously, with this big old bed. So it definitely can do it. I'm happy with the results that I got on the materials that worked well. Obviously, there's other ones that, I wish that cold rolled steel would have worked. But maybe there's a reason why. And if you know why, please drop it in the comments. If you have any experience with this process and using CO2 lasers to cut steel, please let me know. Let me know what I did wrong. I'm up for the criticism because I'm all about learning. But if this is the machine that you've been looking at and you're wanting to know about the capabilities, there you go. So if you are interested in this machine and you need a discount, well, I'll drop all of my stuff down below, but Bearded Build's 5 off is going to get you 5% off of all your purchases over at OMTech Laser. So thank you so much for watching. If this video was helpful, please smash that like button, subscribe, and we will see you on the next one.